So thanks, Sunshine, for the introduction. And I have to say, one of the perks of my job is I get to travel to many places far and wide. I spent much of my career trapped in the South, either the Southern United States or the Southern Hemisphere. So it's my first time in Rhode Island, so it's been fun, and everyone's been welcoming, and it's been great to participate at least a little bit in this particular symposium. So I had a title for my talk, which is Fatal Shores, Managing Climate Risk in Coastal Communities. It's a bit cryptic, maybe a bit sinister. I'll comment on sort of where it comes from in a little bit. But to give you a sense of sort of the ground I'd like to cover, I want to say a few words about Oak Ridge National Laboratory, where I work, so you'll understand the context. I'll say a little bit about what climate adaptation is. For many of you in the room probably quite familiar with it, maybe not so much. I want to link adaptation to concept of risk management. And then the latter 2 points is where I'll sort of dig in a little bit deeper, talk about some of my own research and analyses, trying to assess the exposure and vulnerability and risk to coastal communities, both here and in Australia, and also talk about adaptation planning and implementation. So I'm often criticized for just spreading doom and gloom and talking about the end of the world. So I want to end on somewhat of a positive note, but there'll be some cautionary messages in there. So depending upon what you're interested in, you can decide when you want to tune in and tune out during the course of the talk. So okay, so Oak Ridge National Laboratory is actually has a prominent place in American history as the site where first we learned to process plutonium during the Manhattan Project, and primarily as a site for enriching uranium, again, for the Manhattan Project. So they carved out a niche in the middle of the East Tennessee woodlands, 30 miles outside of Knoxville. Basically kicked a few sharecroppers off their land, and within 1 year built a city of 70,000 people with about 110,000 employees, most of whom had no idea what they were doing. They knew they were working for the war effort, but they didn't know exactly what they were doing until a couple of years later when the first bomb was dropped. And also, many of the employees there were women and young women who actually did most of the heavy lifting in terms of enriching uranium. It continued to serve in that sort of capacity of processing uranium and plutonium for nuclear weapons. Eventually, however, we moved out of that business into peacetime research. Oak Ridge is still now a city. It lives on. But today we've got a very large national laboratory, a budget of almost $1.5 billion, several thousand employees, most of them research scientists. And some of our specialties are in scientific computing. So we have the second fastest supercomputer in the world. We're always playing tag with China. So they put out the fastest, we get a new one that's the fastest, and they beat us. So we're doing tit for tat in that regard. We do a lot of research on materials, a lot of work right now on carbon fiber and additive manufacturing, 3D printing. So if you saw any of the news recently about, it was a vintage Shelby Cobra that was 3D printed. That was done at Oak Ridge National Lab. We've got a neutron source, which, has really wicked science used for studying materials, understand their properties, even though you can't see directly into them. Anyway, interesting place to work, a lot of interesting stuff going on, particularly focused on energy. So within that big complex, I have this role as the Deputy Director for a Climate Change Science Institute. This has been in operation for about 5 years. We have 130 really, really excited employees who are working within this institute. And of course, we want to do the basics of understanding how the Earth system works, particularly with respect to climate. We're really interested in modeling the climate system, really interested in understanding how terrestrial ecosystems respond to a changing climate. But then we also do work in the impact adaptation arena. What are the societal implications of climate change? So that's the lab and where I'm working. I've been there 5 years, and you've heard more about what I've done in the past from my biography, but it's been an interesting path. I've weaved in and out of the sciences, I get restless. But I've always been really interested in not just doing science, but looking at how science is used in the policy arena, or not used in the policy arena, or misused in the policy arena. Okay, so within this research domain, I work by and large on this issue of adaptation to climate change. So what is that? A definition, there's lots of these out there, but this one works. An adjustment in natural or human systems in response to actual climate variability or climate change, as well as what we expect or anticipate might happen with climate change, and their effects. This is both to reduce risk, but also perhaps to take advantage of potential opportunities that might arise from a changing climate. So you contrast this with mitigation, reduction in greenhouse gas emissions. So this isn't about preventing the climate change problem. This is about learning to live with it, but also learning how to do a better job of dealing with extreme weather events and natural variability that we deal with every day. Okay, so the title from my talk. So where I want to start talking about adaptation, I want to go back in time. So I spent 5 years in Australia. It's a very interesting place with an interesting history. There's an interesting book, The Fatal Shore, that I read when I sort of first got down there. It's about the colonization of Australia by the British. As most of you know, although they don't talk about it that much in Australia, it was started as a penal colony. And it's, for those who study adaptation, it's an interesting story, right? So they packed up a bunch of boats consisting of prisoners and largely military officials, soldiers. They made this 9-month journey to Australia. They arrived basically in what's now Sydney. So they arrived in the southern bay down here, Botany Bay. They stayed there for a couple of days and then realized this is not really the greatest place to set up a colony. So they moved around to the other side up to what is now Sydney Harbor, a little bit further north, Jackson Harbor, I think it's technically referred to. It was a bit of a struggle, right? So nobody from the British Empire had been here in 20 years. When the first explorer, Captain Cook, checked it out 20 years earlier. This was in the late 18th century. So they had prisoners, petty criminals, and soldiers. They didn't have any farmers, they didn't have any engineers, they didn't have any builders, blacksmiths. They didn't really have anybody who knew how to do anything, right? And the climate was a little bit different than, that of jolly old, not so sunny England, right? So some of the impressions. One of the soldiers, if we are obliged to settle here, there will not a soul be alive in the course of a year. So that's fresh off the boat, a somewhat pessimistic understanding of their new home. 20 years later, another prisoner said, "Never surely was a more barren land. I thought it unlikely to answer to any good purpose." So this basically, you've got a community of folks who are really poorly adapted to their new environment for any number of reasons. Path dependence, dodgy expectations. They're bringing past practices into a different environment. There's another story. So this comes from anthropologist John Bull, talking about the implications for the Aborigines of Australia. "It seems indeed to be a general appointment of divine providence that the miserable Aborigines of New Holland should be utterly swept away by the flood tide of European civilization." So this is a very large externality of British colonization, which was the decimation of the Aboriginal population and ongoing tensions that exist to this day. So this leads to a comment from Tim Flannery, a current ecologist and prolific author, who said we have to fundamentally rethink the old ideas about the environment that came from Europe. And so effectively, he says, 200 years later, we're still trying to do that in this particular land. So what are those old ideas from Europe? A better perspective comes from this paper that's written by colleagues and friends of mine in Australia called effectively adaptation or manipulation. And they argue that in many cases, societies actually manipulate their contexts instead of learning to adapt to them. Okay, so what does that mean? Let's give a practical example. So my folks are from the Carolinas. This is a scene from the Outer Banks after a hurricane a number of years ago tore a new inlet, destroyed the the main road that's constantly getting destroyed by hurricanes. And as a way of adapting, you just call the Army Corps of Engineers, and they come in and they dump a bunch of sand in there, plug up your inlet, rebuild your road, all good, right? So one could argue that's not really adaptation, because you're not taking into account the fact that this is continually happening again and again, but rather we're just manipulating the environment to preserve the status quo. Now, a natural response, but it also means we're continuing to invest large amounts of money in doing this. Are we going to continue to do this with sea level rise, increasing risk, increasing population pressures, et cetera? So I look at these issues from a risk context or a risk management context. So this is a sort of classic decision-making paradigm that's used not just in the sciences, but it's particularly used in the public sector, it's used in the private sector. The IPCC has started framing their understanding of climate change consequences around this framework. So risk is a function of three elements: sort of the climate hazard itself, which is basically extreme weather events and a changing climate, exposure of population, ecosystems, infrastructure to those hazards, and then the vulnerability of those assets. So what do we mean by vulnerability? It's a bit of a fuzzy concept, but as a case in point, so we're all aware that a pretty nasty 7.8 earthquake happened in Nepal several weeks ago, right? Mass loss of life, mass destruction of Kathmandu. A similar sized earthquake happened in Japan a few weeks later, just a couple of weeks ago. Initial headlines were no initial casualties or damage. Okay? Same size event, very, very different outcome. And so that reflects not the hazard, not the exposure, but yet differential vulnerability of those communities and those people. The other thing about this is it links risk to development. So through development, economic growth, investments in risk management, disaster risk reduction, adaptation, you can influence your risk, either increasing that risk or reducing that risk. And of course, development also feeds back to affect the change in climate. So the magnitude of future climate change is obviously contingent upon rates of emissions of greenhouse gases. Okay, so in that context, now what's always bugged me about thinking about climate change and its impacts is for many years, we really focused on the hazard, right? So really focused on, as an entry point, can we predict what's going to happen with the climate? So how many more hurricanes are we going to get? How big are they going to be? What, et cetera, et cetera. So recent events, such as Sandy, caused massive devastation. Good example of both the hazard and exposure and vulnerability. But then the sort of emphasis becomes on, well, we need to be able to predict what's going to happen with hurricanes, decades to centuries into the future, right? And a lot of papers have been written on this, and they get well cited because it's a big concern. But I would argue, well, you're ignoring a lot of stuff, right? So one, risk is socially constructed, and I mean that in a couple of different ways. Okay, so one, risk is all about perception. Okay, what do you care about? So an example, genetically modified organisms and foods, right? A lot of people perceive that to be a risky proposition, even though there's not necessarily a lot of scientific evidence suggesting that it is a risky proposition, but it doesn't matter. People perceive a risk. So, and that information gets spread, so it becomes a sort of cultural and social phenomenon. Two, it's sort of socially constructed because our decisions about what we like, what we want to do, where we want to live, what we want to spend our money on, who we want to vote for, et cetera, is also a big factor driving risk. So this is the kind of stuff that I focus on. So I'm not a climate modeler, although some of my friends are. So I'm really interested in how that climate information is used to understand risk in its social context. Okay, so one of the metrics I use in this is looking at disaster losses. Okay, so this is economic losses from natural disasters. I kind of like them because it's kind of straight to the point, right? Because that's sort of, well, the first thing you hear about natural disasters, either health impacts, morbidity, mortality, or economic damages. And And it turns out that this is sort of a good indicator of how socioeconomic change and development drives risk. And so we've heard about this earlier this week. So Jeffrey talked quite a bit about development and its implications in a changing climate yesterday. I imagine Claudia talked about it as well on Monday. But the IPCC in their report in 2012, they argued increasing exposure of people and economic assets has been the major cause of long-term increases in losses from weather and climate-related events, right? So we have these data sets. This is insurance data from reinsurance companies going back, a century. And we see this sort of increase over time in loss events. And that's global data. This is from the United States. And we see a similar type of trend toward rising losses. Now, many people will say, aha, that's the climate change signal, right? Climate is getting more extreme, more severe, therefore losses are going up and we're getting more disasters. But by and large, it's not the changing climate. This is a signal of population growth, economic growth. We're wealthier, we're building really, really nice houses on the coast and in floodplains, and therefore we're just getting whacked more and more often. So disaster losses track socioeconomic change. So they track demographic change, population growth. They certainly track economic development. We have some historical data we can work with. Great, surprisingly, the only folks who really do a good job of tracking economic losses from disasters are insurance companies, and that largely is proprietary information. So FEMA, those guys, they've got some information, but it's the private sector that's got the best, and they're not really keen on sharing it. The other thing why I'm interested in this is because, well, we spent a long time investing in disaster risk reduction, right? We actually don't like it when these events happen. They're somewhat disruptive. And there's a lot of policies, changes in building codes, land use planning. So there's a policy history that goes along with this that can help us understand context, right? Okay, so what are my sort of research interests? Well, basically I'm interested in how this type of socioeconomic change, demographic change, economic development, how does that influence risk? Okay, either by, particularly in terms of how it drives societal exposure to extreme events, but also in how it drives our ability to manage those risks and reduce our vulnerability, reduce exposure. So, back to Australia. These two pictures are from the same place. The top, this is Sunshine Coast. Sorry, not Sunshine Coast. It's the Gold Coast of Queensland, and particularly Surfers Paradise. The top one is from, I believe, around the 1950s, and the bottom picture is effectively the same place just a few years ago, right? So it's changed a bit over time. This isn't quite in Australia's Hurricane Alley, but it is within reach of a hurricane. And the storms that they get right now are still sufficient to drive significant beach erosion. And clearly there's some significant property value tied up in this particular location, right? So, kinds of stuff I'm interested in. So what's the relationship between increasing exposure and losses? How is exposure going to change in the future, assuming different assumptions about how we develop? What are the implications of future development exposure for losses? So how quickly are losses might they grow in the future? And what's the relative contribution of the biophysical stuff, meaning changes in climate and storm events, versus changes in socioeconomic exposure? And I'll give you the punchline. By and large, for most things we're interested in, this is a much larger driver of consequences than a changing climate. So I wanted to show you some data of sort of how I'm going about measuring some of this stuff. So this is national land covered data. This is basically a map produced by the US Geologic Survey that shows land use across the entire United States using satellites to look at the land surface. So all these areas in red are basically different types of development, right? And so they put this product out every 5 years or so. They actually have a newer version now. So this is focusing in on one part of Florida, Indian River, Florida, which is somewhere on the east coast there. I forget exactly where, we've taken this data set from 2 different time periods, and they look about the same, right? So, okay, that's cool, no big deal. If you focus in on some particular, okay, well, that's that. All right, sorry, getting distracted. Here we go. So if you focus in on particular spots, however, in the black circles, you'll see that in 2001, there wasn't a lot of development in those locations, and 5 years later, they started to be built out, right? The other thing we've done here, and you can't really see it, unfortunately, on these pictures, is we've put in the 1 in 100 year flood zone. Okay, so what we're doing is using this land use data to basically measure over a 5-year time period the actual amount of development that's occurred within the coastal floodplain of this particular community. And so what we can do is start measuring this. So in this particular community, these are different types of development: low density, medium density, high density. We can measure the area in 2001, the area in 2006, and measure the difference. So anything from a 3% to a 60% increase in those types of developed land areas in that amount of time. So that's just a 5-year period, right? Now, that's apparently a very hot community to be in, so if you expand this out to the state of Florida, then it looks a little bit more modest, but you're still talking about, several percentage points increase in land area within places that we know, because they're defined as such by FEMA as flood-prone areas. Okay. So, who cares? Does that matter? And this is a bit sciencey, so I apologize. But what we're really interested in is, okay, so you've got more development, which means more exposure. How do losses respond? Okay. So what we did was went to FEMA, we took a bunch of data, we looked at a whole bunch of disaster events that have actually happened, and we pulled out what are the preliminary damage estimates. So this is when a storm event happens, the county and the state, they get together, they do a quick assessment of the economic losses, they send that to the federal government, and based upon the population, et cetera, and a threshold, to make a determination that yes, that community is eligible for federal disaster assistance, right? So you end up with a whole bunch of data on impacts from a particular event. So we took 5 years of data from all around the country, a bunch of different types of events, down to the county level, and we just plot the exposure, which is basically the sort of economic exposure of the county, which is population and income, against the losses that occurred. And it's a big, messy data set because you got different types of events of different sizes, et cetera, but hopefully you see a fairly clear relationship of the greater your exposure, the greater your losses. Okay, so that's kind of a duh, right? You would hope. It turns out it's not a one-to-one relationship, so just because you double the number of houses in a floodplain doesn't necessarily mean you get double the losses. And so actually what happens is the greater your density of development, over time it reduces the marginal increase in your losses. And also it looks different depending on what kind of events you have. So we split this out in different types of events: floods, severe storms, hurricanes, and wildfires, and you get different relationships. And so for wildfires, for example, once you get beyond a certain level of density, you're not dealing with a forested landscape anymore, right? You're dealing with an urbanized area. So wildfire risk kind of goes out the window. But the whole point is, so we can now actually sort of quantify these relationships, which allows us to say something about, well, if we know how exposure is going to change in the future, what might that mean for how losses are going to change in the future? Okay. So that means what we need to do next is, how's exposure going to change going into the future? So this is some work we did I published it a few years ago, and we just wanted to map out on the US landscape, so what do we reckon in terms of future changes in societal exposure to natural hazards or anything else? So this is, again, it's based simply upon scenarios of population growth. So we had a demographic model that we ran to grow future population in different counties, as well as scenarios of economic growth. So we have more people or less people, but also wealthier people or poorer people in some locations. So the areas in red are areas that are projected to grow more quickly going into the future. on a relative basis, and the blue areas are expected to grow more slowly or in some cases decline, right? So what do we see from this? A number of things. The South shall rise again is basically the story. So a lot going on in the urban South, not as much going on in the old Rust Belt or the Great Plains, and then a lot going on out in the West. The other thing we see is all around the coast, particularly of the eastern United States, even in places that otherwise aren't growing very quickly, we see fairly rapid rates of development, right? So that I said, well, this is interesting. That means these sort of coastal areas are hot spots for future changes in exposure, future development. It turns out coastal areas also tend to be exposed to some nasties, particularly in the eastern United States. So we said, can we estimate these kinds of effects? So what we've done here quickly is, so we took three different things, right? So we said, okay, first we need the hazard, right? So we took some storm surge model data and integrated different sea level rise scenarios into that, so we can map out everywhere from Texas up to Maine what the future inundation risk from hurricanes might be accounting for sea level rise. And so you can do these funky visualizations in Google Earth, but it takes a lot of time, and so, but it looks cool, right? And that's just what the model looks like in its more native form. So we're using scenarios of housing. These are scenarios developed by the EPA. They're interested in pervious surface and water quality impacts of development, but in so doing, they develop these really high resolution scenarios of housing density for the whole United States. And by high resolution, I mean 1 hectare resolution, so 100 meter by 100 meter grid. So we have that over the course of the next century. And then we need some economic indicators of how the economy is going to grow. So we took some GDP scenarios for the United States and used those to develop some county level estimates of economic growth. So we've got these three components of a hazard: housing, population development, and economic development. So then what we start doing is start putting all these things together. And so what we've done here is integrate our housing scenarios and our inundation scenarios. So before you look at those, simple schematic, we have a hazard, which is some storm surge inundation data. We put the housing data on top of that, and we pull out whatever the intersection is. Okay, so we focus on housing in areas that are subject to inundation. So this is an example from the Hampton Roads area of the housing density data, what it looks like. Here's an example of some of the storm surge data, what it looks like. And then we start putting these two things together. So this is a Category 1 storm surge plus the 2005 housing density estimate. So we're only looking at housing density in places that are subject to a Category 1 storm surge. And the red areas are higher levels of density, green areas, lower levels of density. This same plot, only now we're looking at a Category 3 storm, and we've included an allotment for sea level rise, and we're looking at 2,100 housing density. And so you've got a lot more exposure because you've got a lot more area inundated, and you also just have a lot more people on the landscape. So this allows you to do things like plot out over the next century the sort of trajectory of growth in exposure. So we use this metric, we called it, what do we call it? Exposure multiplier. So how much is exposure going to grow as a multiple based upon these different factors? So we have a time series, we have our exposure multipliers, we have different scenarios. So each curve represents a different scenario, and that just reflects different assumptions about rates of population growth, rates of economic development. They're consistent with the IPCC's SRES scenarios, if that means something to you. But in any case, different uncertainties about future development. So what we see is housing exposure increases by a factor of 2. So just the housing component increases by a factor of 2 over the course of the century. And that's across the eastern United States. If you look at specific locations, it's much, much higher. But on average, housing exposure doubles. this is this sort of economic exposure. So this is what happens simply due to people becoming wealthier. It increases by a factor of 5 to 10, and the uncertainty is much broader among the different scenarios. So the fact that people are just going to be richer going into the future turns out to be a big component of future exposure. And what we can do is put those two things together. So the total exposure increases over the century, by the end of the century, by a factor of 10 to 20. Okay. So I don't know if those are big numbers, small numbers to you, but let's say at present, annual losses from hurricanes are $10 billion. That's an approximate estimate. That's in literature. So by the end of the century, we're sort of up there in the $200, $250 billion range per year, assuming, of course, no big changes in policy or anything like that. And that's $2010, right? So, how do you interpret that? Does that matter? It depends. So some people would say, well, this is just a function of economic growth, right? The economy gets bigger, losses get bigger, so what? It's a sign of success, it's all economically efficient, no problem. Others would argue we should probably start trying to get a handle on this particular problem and figure out how we can decouple population growth and development from exposure and loss. We can also split this out and look at how this changes in sort of a county by county level. So we're looking at changes in inundation exposure for all the counties along the East Coast. So the big red blobs are the highest level and the small blue ones are the lowest level of change in exposure. And not surprisingly, your big changes occur in areas that are already highly populated, which means they're urban, which means they're growing more quickly. So in Texas, not surprising. Florida is just a problem child for any number of reasons. Even southern Georgia is growing fairly quickly. So that gives you some spatial disaggregation. Okay. So that's really the exposure component, right? And so when you try and publish this stuff, people can give you grief in your peer review because they'll say, well, it's just exposure. It doesn't include sort of this vulnerability component. So you can probably imagine a future where, yes, we have lots of people and they're all very, very wealthy and they're living right on the beach, but it turns out that in the event of a big hurricane, they don't lose anything because the way they've engineered their property or what have you, right? So this vulnerability issue. So there's a lot of effort right now invested in measuring vulnerability or measuring resilience or measuring risk, developing indicators or indices of this. It turns out that this is just really, really hard, right? So we don't really have a good measure of vulnerability. What we have are proxy metrics. And so the idea is, okay, poor people are probably more vulnerable than rich people. And so if you look at the global maps, they'll say things like sub-Saharan Africa, the people there are really vulnerable, which is all well and good, but not terribly informative, if you ask me. And then things like education, how well institutions work, corruption, whether or not people are insured, things like social cohesion, probably a big factor driving resilience during extreme weather events, but how do you measure that? It's actually sort of difficult to go out and interview people and say, do you have a strong social network? How do you validate that? So, you can take these kind of indicators, put them into indices. So this is stuff that Susan Cutter has been doing at the University of South Carolina for a number of years, and you can map out areas of greater or lower social vulnerability. So the band that sort of shows up in this plot sort of maps out the Southeast Black Belt, which is this area of sort of rural minority farming communities that tend to be poor and disadvantaged. So that shows up in this literature, but in this type of index. But then the question becomes, well, what does that tell you? Can you use that to predict anything, right? So does social vulnerability tell you something about how many economic losses you're going to get? No, because poor people tend not to lose as much economically as rich people. We see it all the time. Natural disasters, floods in America versus a developing country, right? Much bigger loss of life in a developing country, but the economic losses are kind of trivial by comparison. So you need indicators and indices that are specific to the type of outcome that you're interested in. And some circumstances, the so-called poor people are often more resilient, less vulnerable than rich people. You know, if you go around anywhere in the United States and you have a blackout, you know, people kind of freak out, right? But people who live constantly with blackouts or don't have electricity, you know, they can cope with that just fine, right? So it's nice to have these things actually predict something we care about, and to do that, we need something to validate them against. Okay, so that sort of work I do on the risk assessment, assessing exposure, and hopefully I've been able to convince you that it's not to say that climate change isn't important, let me emphasize that, but that you know, when thinking about future risk, it's not just about making some projection of how the climate is going to change over the next century and then superimposing that onto the current day state and thinking that means something, because it probably doesn't. Okay, so enough doom and gloom. Human beings are an adaptive species, right? So yes, when the British rocked up to Botany Bay in Australia, they had a pretty rough time of it, but you know, now there's this sort of bustling, thriving, and rapidly growing community that does pretty well in lots of things, except not so much in the World Cup, you know. But and I say that, you know, as both an American and an Australian citizen, so I get to pick my allegiances. Okay, so back to adaptation. So what's happening? Lots of stuff. So at the federal level, Obama's passed multiple executive orders to encourage a more resilient stance on behalf of the federal government. So all federal agencies are now required to develop an adaptation plan and identify their vulnerabilities to a changing climate. More recently, there was an executive order sort of changing the way that floodplains are identified. One of them being you can use best available climate science, but nobody knows what that is. So in some ways that introduces policy uncertainty. But you know, these are sort of efforts, so these signals from the top down. Most of the action is at the state and local level. So this map is from the Georgetown Climate Center. And the sort of blue areas, sort of dark blue states, are those that have an adaptation plan in place. And the lighter blue are ones that are working on it, right? You can see it's not a random distribution. So it turns out it's the sort of the East Coast and the West Coast and Colorado, you know, that are working on, have done some adaptation planning, right? And this might match up with red states, blue states, but there's a bit of a gap in the middle of the country there. And a whole bunch of stuff going on. So all little black dots are individual cities, right? So that's where a lot of the action is at. One of the things that this raises for me is this issue of, well, that's fine if you say, well, I live up there, so I'm cool, right? But chances are, to some extent, you're dependent upon stuff happening in the interior of the country where people don't want to talk about this, right? Agriculture, for example. So there are these sort of teleconnections or linkages between what's happening in one place and another place. So again, just like people in the Midwest care about how much money the federal government spends on hurricane disasters on the East Coast, people on the East Coast should probably care about what's happening in the interior of the country with respect to adaptation planning. Not to pick on anybody, but you know, Texas has had some issues as of late with flooding, and not only do they not have an adaptation plan for the future, they don't even have a plan for the present, right? Hence, they're a bit wet right now. What's happening? Some examples of local planning. So, you know, Boston's done this. They've done heaps of stuff, big documents, lots of things they've identified, and maps showing risk. And New York City's been doing this for 15 years. It goes back to 2000 they started doing this. They have advisory boards that are institutionalized by local laws. They have a whole Plan NYC planning process that they're implementing. And so they're just doing this iterative risk management thing. And so they're sort of the poster child for how to do this if everybody's got as much money as New York City does. And then, so I lived in Melbourne. There's Melbourne Cricket Ground, and that's where the Australian Open's played if you're into tennis. So they did this a number of years ago, as did a number of communities around Australia, and then London's done this as well, and the sort of list goes on and on and on and on now. So what are folks actually doing? There's a variety of these, I get messed up. There's a variety of sort of standard coastal adaptation practices that people implement. Protection, accommodation, retreat. So protection is like build a seawall, beach nourishment. Accommodate is like, well, put everything up on stilts so let the water just run under us. There's the running away thing, which there's a number of formal names for that. So you can buy back properties, you can increase setbacks so you can't develop so close to the coast. You can do rolling easements, which just says we're going to let your house fall into the water tough. And then there's a whole bunch of other sort of cross-cutting stuff. You can just do a better job of assessing risk and communicating it to the community. So there's always there's all these options that are on the table, and this is just for the coast, right? Just for coastal communities. Just as a reminder, every community that's on the coast not only has to deal with what's coming in from the ocean, it's got to deal with a whole raft of other stuff, right? So it's not just about sea level rise, it's also about stuff like this. So this is the Black Saturday bushfires, which hit Victoria, Australia, and particularly just north of Melbourne. And this happened when I was living in Melbourne. So you had a nasty bushfire event that coincided with a nasty heat wave. What are the statistics on this? So this is the worst natural disaster in Australia's history. 173 deaths due to the fire alone. Several hundred deaths due to the heat wave. Those weren't as widely reported because they weren't as dramatic, but the death toll is actually higher. And a whole raft of additional impacts associated with this nasty heat wave. Temperatures hit 113 degrees Fahrenheit. Australia is warm, but that part is not that warm. And this is a coastal town, right? So they have to deal with hail events and fires and all the other things that every other city has to deal with in addition to the coastal stuff. So this is an analogy I like to use. So that's sort of, that's all those coastal adaptation options. That's all these things that we can do to reduce our risk. But we have to distinguish between the sort of planning and the implementation. So what we see right now is a whole bunch of folks doing a whole lot of planning, right? Lots of paper or digital paper being used right now to develop these plans, assess risks, identify things they can do about them, say who's responsible for them. So if you tally these things all, there's thousands upon thousands of adaptation options that could be implemented to address risk. But the implementation thing is the big problem, right? Why is it such a big problem? Because we all care about different stuff, right? So this is all pictures I've taken from different coastal spots. And it really is designed to reflect different values, right? Why do we care about the coast? Well, we care about really nice property. We care about businesses, whether it's a little shack on the beach in Colombia or a cafe on the coast of the North Sea in Germany. We use the beaches and coast for recreational activities, for biodiversity, transportation. We install art on the beach. We like the scenic amenity, and we care about future generations, right? If that means picking up a lighthouse and moving it, as they did in North Carolina, and that's actually my daughter. She's a little bit bigger now, but I'd like her to be able to visit, the beaches that I visited when I was a kid. So a lot of values sort of at play. And in the interest of time, I'll just show a couple more, right? So we did work, again, this was a couple of years ago, we did work at Australia talking with stakeholders in local government. I worked a lot with local government stakeholders in Australia. And one of the things we asked them is sort of what drives your decision making in the coastal zone? And the bars sort of indicate, prevalence of responses. So lots of green means that's a popular response. And this is ranked in order. So the most popular response is, hey, we basically do whatever state government tells us to do, right? So that's the driver of decision making. followed by, well, if we get some more information about what's happening with hazards or climate change, we might use that to drive decision making. Or a big one, we're afraid of getting sued, right? That's a big driver of decision making in local government. So if those are your drivers, and you start to see that what you would like to be able to do on adaptation isn't what you're always able to do, right? Because you're constrained from different angles. And we've looked at this. So we took all those same adaptation options I showed you before. And the reason why I picked those is because we use those in a study. We basically went out and interviewed people in local government and said, how well do you think these different adaptation options perform in dealing with different types of coastal risk, right? And so the responses are on the right. That means this thing performs really, really well. And on the left, it performs not so good. And we asked them to look out over different time frames. So the yellow is looking out how well they perform over the near term versus red, which is thinking more of the longer term. And what you see is generally the sort of protection measures, building seawalls, beach nourishment, local government staff, not too keen on those, particularly not keen on them over the longer term. Yeah, you might do them over the short term, but they're not going to hold up. They're going to be increasingly problematic over the long term. Whereas increasing setbacks, blocking development, rolling easements, and community education, all that stuff generally performed well and it held up over time. And I don't think that's terribly surprising, but you see, the point is you see these very strong preferences among different people, particularly folks in local government, about the types of options they prefer. Now, how well local government staff are able to pursue those options that they prefer, given there's state government, there's elected councilors, there's the residents of the community, is a big challenge, and therein lies the problem. So again, just what people in local government might plan to do because it makes sense to them isn't necessarily what's going to get implemented. And I think I'll sum up with these points. Exposure matters. Exposure is increasing. We're doing a lot of planning, but it remains to be seen how well that planning actually works in terms of being implemented and actually reducing risk. I could have just made all those a lot shorter, couldn't I? Thank you.